from Sri Lanka. So you have to forgive me, it's not my specialized area, but to suit your conference, I gathered information and prepared this presentation. Also in this presentation, you will find that rather than suggesting on the innovative solutions, I have tried to emphasize you the need for sustainability. And I think first we need to understand that, and then we can see the innovative solutions as the remedy for the situation. If I start it, what is sustainability and why it is important? I have got these definitions from the published document. Yeah, past one, previous one. Yeah, basically we all understand sustainability addresses ways to protect and conserve the environment. Basically, how we manage today while protecting the rights of the future generations. If we just keep on consuming the resources on our own, so we are putting our future generation at a very high risk, and our populations are also growing, and we have now reached more than 8 billion by now. So these are the basics on the sustainability. Then the solutions which we look at is mainly on engineers' hand. So whatever the problems we have in the world, I think majority we engineers are responsible. So if you look at everywhere, it is engineering. You walk, you sleep, you go anywhere, and it's totally engineering. So we finding solutions. It is again we engineers have to do it. And if it is sustainable development, yes, it's sustainable engineering. So if you look at the sustainable, what is sustainable engineering? It is the process of designing or operating systems such that they use energy and resources substantially. In other words, at a rate that does not compromise natural environment or the ability of future generations. So I have highlighted the important words to meet their own needs. I think that we need to first understand. So, next. Then, as you all know, having understood the need for sustainable development, the UN in 2015 published the SDGs. I'm not going to detail, but you all know 70 SDGs, and that emphasizes the interconnected environmental, social, and economic aspects of sustainable development. And now, I will not go into detail all 70, but now there's a question whether we can reach the set target. Time is moving very fast. Now we have set the deadline as 2030. Can we reach this target? That is the big question we have. Do we have the conventions every 2 years, 5 years? And we discuss, we pass new rules, but still, practically, can we meet this demand? So, can we ensure the future we want? So this is the question we have to understand. Next, please. Sorry. Yes. Then we come to the question: we having understood the sustainability, need for sustainability, why innovative solutions? Now, as I mentioned in my inaugural speech, the current day issues are technically, financially, environmentally complex. Why do I say so? You all know now from my specialization in the water resources and hydropower. The world potentially in many countries we have already exhausted. We have harnessed whatever sites remaining are very complex, either geologically complex or with other technical, even the equipment selection in many aspects technically complex. And also financially also is complex, because we all know in the developing world, we simply identify a project, prepare the basic concept, do the pre-feasibility, and we used to simply go for a standard lending agency, we get money, implement it. But those days are over. Now, many of these we were getting the concessionary loans, the grants, everything. It's not possible. So we have to go for new models with the public-private partnerships or the various other or wood, the BOT or the BOT or the wood and various mechanisms we have, buyers credits, suppliers credits, so various new mechanisms we have to implement it, to use in implementing this project. In my experience, we had in Sri Lanka, we implemented 2 such projects with totally new financial model, which we have never tried before. And then environmentally also very complex. Environmentally, the restrictions, social restrictions, the many ways. You see, not like those days, you need to meet various regulation restrictions. Implementing a project is, is almost impossible sometimes. So, with the strict environmental regulation. So, this is, but still, can we, with all these restrictions, can we just stop development? No, we need, because our demands are growing, energy demand is growing, water supply demand is growing. Yes, for the water supply, we need to build large reservoirs. Building a large reservoir is an impossibility today. In our context, I think even India is the same. Because the large, when you have a large resettlement, impossible. But sometimes when you look at a reservoir project, you can't select any other place. That's the only place possible with a nice valley and with the topography suitable for a reservoir. So then what's the answer we have? That's what I say, the available technology is also not sufficient to address that situation. So we have to be innovative. We have to go with new solutions. That's what I say. All we seniors have all exhausted the available textbook solutions, and then you will have to design, establish new theories, new ways to interact with the new problems we are facing. Then, as I mentioned in the content, so let's look at the water sustainability. So, just to emphasize you the importance, the water conservation. Why it is important? If you look at, especially in agriculture uses about 70% of the world's fresh water. I think we have not thought about it. As per the UN records, the fresh water demand for the agriculture is about 70%. And farmers can conserve water by planting crops that are suited to the climate where they are planted. Farmers can also collect rainwater and use it for irrigation. These are other opportunities we can think about, but still, we have just started to look into this. So this is very important that if we are to go with the available statistics, seriously we will face problem in the near future. Then if we talk about water, the importance of water, I found this interesting quoting. This is from the Australian Aboriginal proverb to show how the water is connected to our life. It says, I will quote it here, if the water is healthy, the land is healthy. If the land is healthy, then the people and the culture will be healthy. So this is very important. This reveals the cognizance of the strong interconnections among land, water, people, and culture. This one aspect, the water, if we can address, we can see how interrelated and how important it is in our life. Yeah, please. Then similarly, if you look at about the water demand, the most countries are placing unprecedented pressure on water resources. As per the World Bank report, the global population is growing fast, and estimates show that with current practices, the world will face a 40% shortfall between forecast demand and the available supply of water by 2030. Now, these are with all the SDGs and other regulations in place. Furthermore, chronic water scarcity, hydrological uncertainty, and extreme weather events, floods and droughts are perceived as some of the biggest threats to global prosperity and stability. So the feeding 10 billion people by 2050 will require 50% increase in agriculture production. That means as I mentioned before, which consumes 70% of the fresh water demand. So how are we going to meet all that? And 15% increase in water withdrawals. Besides this increase in demand, the resources already scarce, and in many parts of the world, estimates indicate that over 40% of the world population live in water scarce areas, especially Africa, if you look at, and approximately 1/4 of the world's GDP is expected exposed to this challenge. By 2040, an estimated 1 in 4 children will live in areas with extreme water shortages. Water security is a major, often growing challenge for many countries today. So this is just to emphasize the importance. And also, if we go further, you are talking that the climate change will worsen the situation by altering hydrological cycles, making water more unpredictable, and increasing the frequency and intensity of floods and droughts. Roughly 1 billion people living in monsoonal basins and the 500 million people living in deltas are especially vulnerable. I think you all saw what happened in Pakistan recently. And the rivers happened in Malawi, one of the biggest reservoirs, depleted completely. Lots of people were depending on that reservoir. So totally the opposite happened there. The damages are estimated at around 120 billion per year. That is only from the property damage. And the droughts posed, among others, constraints to the rural who are highly dependent on rainfall variability for subsistence. While some countries have understood the gravity of the issue, there are still in the developed world it has not yet spread into the mainstream thought, and the availability of clean water in their taps is taken for granted. Water saving is not a pressing concern among them. This is a very serious thing we need to consider. The 17 UN Sustainable Development Goals set ambitious targets to date. Success in meeting the goals has been limited, and with 2030 just less than 7 years away, it seems highly unlikely that many or if any targets will be met. This is what I mentioned earlier. So this is a question we need to ask ourselves. So we also find that the public's perception of water availability is lacking. They have no concept of how much water they are consuming. For example, daily use per person is around 20 liters, when it is actually close to 150 liters. Education is a big issue, and the role of government and media in many instances are inadequate. That you all understand. So we complain that if you look at the research today in the world by the developed countries, we contemplate on development of aircraft without pilots and vehicles without drivers, more and more elaborate space travel to distant planets. We spend billions or trillions of dollars in this type of research, but still, are we paying attention with same gravity to address the planet's biggest would-be issue in the coming decades? And this is a question we need to ask ourselves. We in this part of the world, that is in Asia, we treat water as having a particular cultural and spiritual sonority for us. I think in India, I think it's not a new thing to you. I quote a very interesting statement by veteran water professional. Maybe you all have heard this in the International Water Association Director General, Dr. Kala Vairomurthy. He mentioned this. I quote from him. What his father has told him. I think this is especially for the young engineers who will like it. It's a very interesting one. He says, I quote him, "We are the custodians of water. When you use water, think of it as taking a book from a library. You take it on loan and you use it wisely for your benefit. When you finish using it, you need to return it in a condition knowing that someone else is going to use it after you, that you might want to receive it yourself." I unquote. And it's a very interesting and it gives a very important message to us of the world. So this philosophy stood in my country. I think, of course, in India, I know we are aware that in the same actually India, and they are the great kings of the second and 2,500 years ago. Developed one of the finest hydraulic civilizations of the world. If you look at the, the ancient hydraulic civilization both in India and Sri Lanka, we still, some of the theories we can't understand. I just want to mention you here one example. When I did my high master's degree in Norway, Trondheim, Norway. So during that, it was in 1997. Yeah, 97. One of my professors, Professor Bro, he has never been to Asia. He's a famous professor in hydropower, still living. So he happened to visit India and Sri Lanka for the first time. While we were studying, he got a conference in India, and he said, okay, I'm going to India. At the same time, he will visit Sri Lanka also. So we arranged him to visit places, interesting places. And after the 2 weeks study, he came back. Then the first thing he did, he summoned all of us students and asked a question. The Asian students, that they were friends from India, Sri Lanka, Nepal. So he said he feels shame and asked why you all came to Norway to learn hydropower when I look at your old hydraulic structures. So actually he is a very honest and very humble person. He said that he couldn't believe, having seen our old canals, old reservoirs. Today we are designing structures for 100-year lifetime. We have dams more than 2,500 years old. I think in India is the same. So where are we? So where is this technology? How we missed it? Still. So, but today I'm going to next. If you look at today, the first day, these tanks were built in cascading system using natural topography of the land. The multifunctional system supported agriculture, wild animals, and biodiversity, allowed rice to be cultivated all year round, regulated the local microclimate, prevented floods, and controlled evaporation. If you look at all this now with the old systems, we have not heard about in records so that abundant reservoirs have been heard in India, abundant reservoirs. No. Now today we talk about reservoirs filled with sediments. So something wrong, and we are giving various excuses. The water motors are not sufficient, under-designed, various things. But if you look at all these systems, I have studied in one ancient reservoir system. They have small tanks surrounding the main reservoir to catch sediments. So that is how they plan. The main reservoir is intact. So they have never faced sedimentation issue. And also the water release control, various technologies they have used, but today, unfortunately, we still are trying to understand the theories they used at that time. So then I found it very interesting. With this system poorly understood by modern day engineers, knowledge was lost and infrastructure was either neglected or allowed to destroy, particularly during the colonial era. Now, in the face of climate change, there's a realization of what had been lost, and inroads are being made to rejuvenate this system. Actually, now maybe you have examples in your country, but in Sri Lanka with the modern day planning, with all the new sophisticated software, we have developed water resources schemes. Some do not get sufficient water, some are filled with sediments, various issues. But at the same time, if you look at, when developing all this, we have ruined the old canal system. They have built using along the contours. So still, we do not know why they selected those particular heights, levels, etc. at the particular locations. So without neglecting, by neglecting those, we build new ones with modern technology, but they have failed to serve the purpose. So this is something we need to dig into the ancient theories, ancient engineering, and see where the thing we have gone wrong. Next, please. So therefore, it's of utmost importance of conducting applied research to understand those ancient technologies and to see the possibility of engaging them in today's context as innovative solutions. I think this is applicable to many countries, and each, if you look at, we all have a similar background, but unfortunately we have not paid attention. Now, I think you may have heard about in Sri Lanka we have this fortress called Sea, nominated for as a world wonder. So we are trying to find out how they pump water up. So there are swimming pools used by the king, and we find the pipelines, the construct on the rock, pieces of old pipes also there, but still we do not know how they pumped up to that level. But recently they also they found another similar rock close to it that has been developed as a rainwater harvesting basin. So earlier it was thought as a natural rock, but lately archaeologists and some scientists found out that it's not natural, but this rock has been carved out to act as a rainwater harvesting basin. So today we talk about rainwater harvesting, that it says that they have also considered long ago, but still we have failed to understand the full theory behind this. So this is all about the water sector. I wanted to mention that we understand why the threats we are facing with the water supply for the future and how innovative we need to be. I have not talked about the innovative solutions. I think today we are talking about RO systems and groundwater exploring methods, but still we need to go beyond that and to see how to meet the future demand in the water sector. Then I would like to focus on the construction industry, construction sustainability. So just to mention about the basic construction that requires a large amount of steel, concrete, wood. I don't want to go into detail, you all know very well about it. Other materials. So the one way construction can be made more sustainable by using recycled materials. So if you are talking about sustainability, and this is one next major sector we need to touch and look in for innovative solutions. So one such solution is the recycling material. So that is such as metals and concrete from demolished buildings, sustainable building design, or green architecture focuses on making so each structure waste as little energy as possible. For example, some buildings are designed to collect and store energy from sunlight to use in heating the building. Builders can also install a cool roof made with materials that absorb heat, less heat than a traditional roof. This keeps the building cooler during the hot weather. There's only one aspect actually. So again, under the construction, we need to think about sustainable sites, that is selecting sites. Then the water efficiency, large construction site is connected with the huge water demand. And then similarly, materials and resources, energy and the atmosphere. So when we address the construction sector, it covers again large wide areas what I have just listed the item. So then there we can have many solutions as innovative solutions. Yes, I think if you check, many institutions are doing research on the alternative materials. I think now, I think we have gone to a very far. I mean, we have done in-depth research and found many alternative materials, and they are being used. So similarly, most of the areas have been covered. Then under the innovative solution, the other possibilities are the engaging the digital construction. I think this we have started in some countries, have already gone into this using digital technology in construction. So globally, the built environmental footprint is expected to double in size by the year 2060. For this to happen in line with net zero target set by us, technology will have to play a lead role in improving the way construction is carried out. I think you all are familiar with the targets now in Sri Lanka. Our net zero target is 2050. That is the target set by the government, but we are not sure whether we can be near to it. I think similarly in India, you have your own targets, green energy targets, and the net zero targets. But to be realistic, this is one area we need to, the one major area we need to concern. And so again, getting into digital construction is can be considered as one major contribution. So for technology to advance our construction techniques, digital literacy is going to be required in all practices and to all phases of construction. I think you all are familiar with the BIM. Now BIM is widely used, but still, again, we can't simply put BIM, we can directly put it in, so we need some preparatory work. So there are cost constraints, it's not all the projects we can adopt. So we need to use it from pre-construction process to final O&M. But some stages we can directly use, but to put it in the full phase, you need to do more. Yeah, please. So if we continue on this, to make a practical reality, the technology will have to be easy to develop, deploy and adapt. That's what I mentioned earlier. So that is, if deploying of technology requires weeks, months-long training on the ongoing work, it will not happen. The developers or the clients will not agree to do that because that means it involves cost. So, but long term, we need to get ready with our university education, our training colleges, and we through various other programs, CPD programs, we can apply for practicing engineers. So we need to do it. So in the long run, we need to invest more in improving digital literacy, especially by the contractor. Basically, we have to build up the required digital muscle in organizations. So in all the major organizations, we need to concentrate, we give more concern on the digital applications in the construction industry. That's why I said we have to have separate arm for the digital muscle to be successful in the future. Industry has made great progress in use of technology in recent decades, but we have only scratched the surface. The best is really yet to come. With the digital applications, you can do more in this sector. Next, I would like to talk about energy sustainability, the other third important one. The energy sector is undergoing rapid transformation with the adoption of new technologies and the increasing focus on sustainable energy solutions. The transition from fossil fuels to renewable energy sources is gaining momentum, and new innovations and trends are shaping the industry's future. Most of the countries have defined their renewable targets by now. Sri Lanka, the government target by the government is 70% of renewable by 2030 now. When you say 70%, we have already exhausted our hydro potential. The rest we have is mainly the solar and wind. Yesterday, I learned that your airport is a totally solar powered airport. I learned from Dr. Vasudev yesterday, so it's very interesting. So there are many such initiatives we can do in the energy sector. But again, as you all know, the renewable, the problem with the intermittency and the cost. So can now country like us, yes, can simply be 100% dependent on solar? No, it's not possible because there are technical constraints. And then also the economical. Because though solar is free, the conversion mechanism is expensive. The technology it says that in the future the new technology will come, the solar cells will be printed like paper. I have learned that, I have read somewhere that in Germany they have already made the breakthrough, and it is to be coming to the commercial operation soon, so that solar cells you can print it on any surface, in a curved surface or anywhere. It's like printing, normal paper printing, and simply connect the circuit and get the power. So there will be drastic reductions in the cost in the future. And then similarly wind energy. So renewable energy is one of the most significant trends in the energy sector today. The increasing adoption of renewable energy sources such as solar, wind, and hydro is driving the transition from fossil fuels. According to the International Energy Agency, that is IEA, renewable energy will be the fast-growing source of energy over the next decade, with solar leading the way. The IEA predicts that by 2030, solar power will become the cheapest source of electricity in most countries. And also, it says the future will be solar because our existing petroleum resources will deplete. It says in 50, 75 years, right? But again, and these are the predictions. And also with the coal and other thermal, with the climate change, the global warming, it can be, though we have it, can we use it? Today, I think climate change is, I think we all experience very much the serious drought, serious floods, all that. In many places we see that these are results of climate change. So with that background, can we use those resources although we have sufficient quantity? So renewable is the only answer. And again, the barrier is with the technology and the cost. So for that we need alternative solutions or the innovative solutions. So these are the areas we engineers need to focus on. The adoption of energy efficient technologies such as LED lighting, smart thermostats, and energy efficient applications is a must. So the implementation of building codes and standards that require higher energy efficiency is common. Same way we use find new technologies, we also need to have our regulations also in place, otherwise you can't simply adapt it. So those are the basic main areas I want to touch under the sustainability. Now I want to share some experience in the innovative solutions in Sri Lanka used by our industry. Next please. So some statistics about Sri Lanka. And if you look at the carbon footprint, very small, we are still less than 1 ton. Means we are still a greener country. I think India figure is also there. Yes, India is 1.6 tons. We are still also the same side. The 70% renewable target by 2030 with wind and solar, but fast increasing. Fast increasing. Ideal country. This is the ideal country for solar since 1 kilowatt can give 4 to 6 kilowatt hours per day. Actually, we are solar is one of the best countries for us, except the cloud effect. We have no problem from 6 to 6. We have sunlight, sufficient sunlight. Then UK, Germany, or European countries with temperate climate. The government policy in Sri Lanka is more geared to support green and increasing the forest cover. So that's also one concern under environmental sustainability. Natural resources based building materials are short supply and hence a good demand for alternative building materials and waste-based building materials. Now, energy sector, yes, we can go in the renewables. In the construction sector, the innovative solutions we have done it mainly on the construction techniques and the materials. Yes, the different building materials. These are actually based on some of the university research, and they are being used at the moment, not in full commercial scale, but in small scale. They are being used, but soon it can be come into full commercial scale. Some are the earth-based building materials. Use of earth as a foundation material. Then EPS, this expanded polyethylene, I think you all know, based lightweight panels, 80 to 90% already used. This is also a tool material we can use, and also EPS and fly ash from coal power plant. We make bricks out of the fly ash comes out of our coal power plant. We have only one plant at the moment. I think maybe some of these you used in India already. You have done research. Then also we have an application with a straw-based panel for construction and repair and reuse of building as a sustainable strategy. And very recently they also introduced, normally in buildings we used to adopt 4-inch thick walls as partitions. So with the research they have done, they have found there is sufficient strength to reduce it to 2.5 or to 3. Then you have practical limitations of construction, but still it's also a cost-saving solution and it has been identified as an innovative solution. So the strategies are to minimize or migrate. This is the water sector. What we can do under the as strategies. The applied in Sri Lanka. So the stormwater runoff may include using pervious materials to reduce the surface flow. We're using pervious paving materials on the clay to absorb the stormwater, and also harvesting stormwater for reuse in irrigation and indoor non-potable water applications, designing infiltration swales and retention ponds, planting vegetated filter strips, installing vegetated roofs, and clustering development to reduce paved surfaces such as roads and side roads. So these are the some of the innovative work done in Sri Lanka in the construction industry. So these are the pervious layers or the kind of bricks that you can use for surface laying, and it will absorb and transfer the water to the ground while reducing the surface flow. It helps to reduce floods. If you look at now, most of the time we experience severe floods because of the extensive rainfall intensity that we experience currently due to climate changes, and our design waterways are not sufficient to cope it. If you look at the goals, we design the general water outlets for 25 to 50 year return or 50 to 25 year return period floods. But in one rain you experience more than 500 year return period flood. This climate change, all statistics have gone upside down. So these are some solutions we can use in the public, private roads and the common areas. And also the techniques to prevent surface erosion. These are very basic. This again similar permeable paving methods they have developed. Yeah. And this is the swales I mentioned actually. So without huge drain construction with concrete walls or rubber walls, with similar such a swale can be introduced, and it's environmentally friendly and also appearance also good, and it will drain the surface runoff without making a flood condition. Yeah. So these are some of the photos I copied. The surface rooftop gardening, and then you can reduce the heat load of the buildings, and the sediment control. Okay, so I can share this presentation with you and go into details. Yes, use of daylight. Actually, other possibility in our design we do a mistake. We cover everything and we put light to increase the light level. So why don't we use sunlight directly? And this also one mistake we do in planning. We have not thought about it. So this is also one aspect, and there are 3 such buildings they did with minimum light, artificial light usage. So one is a library, and the other 2 are common buildings. So that way also we can consider it as an innovative solution, and we can reduce the demand of the energy in a building. Then also the material usage, the materials, buildings without the plaster, that also you can do a greatest saving, and with good appearance if we plan the construction properly. Yeah. Yeah, we discussed about the green roofs. Yeah. And also allowing native trees that will not need extra water for survival. Actually, now during construction, what we do, we simply remove everything and start building. Then after that, we go for a landscape. We get the services of a landscape expert. We pay and plant new trees and try to create a result. But if you plan at the planning stage, if you consider if you can leave those, it will help the environment and also help the control in the groundwater. So artificially created ponds to capture stormwater and save water used for irrigation. Actually, if we can capture this water, I have read in US they have schemes during high flood time. They arrange that water to recharge the underground aquifers. So that way, rather than it's wasted, so you can use it to recharge the aquifers. I think this is something recently we discussed, especially in our Sri Lanka, the northern part, the Jaffna, the closest town to the India. I think you all know there's a huge water issue, water problem. There's no sufficient water because the subcontinent is on a limestone base and it's saline water you find. You don't find natural groundwater there. And even though we have water lenses, it's also very limited. So artificially you need to supply water. But and then with the climate change, they also experience severe floods. And a few years ago we experienced this. And now frequently this is happening. So then we are thinking of the possibility of why not use this water to recharge the huge complex of aquifers we have there. So these are the possibilities, new areas we need to do research and study. So again, this is on the timber, using timber in the innovative way in constructing a building. Yeah, then also when you have the water bodies, as I mentioned, the natural ponds to collect warm water, the storm water, we can make the environment also beautiful and attractive. So this again a picture of a factory, the nature. And yeah, this landscaping also you can use the CSR material. Yeah. This is a cascade system they use to. This is we have one major factory in Sri Lanka. They have adapted all this in the factory premises, and it's a award-won location. It is a place to visit. So there are buildings, all energy efficient buildings. The surrounding premises also they are used various techniques like this, and it's a totally environmentally friendly solution. So this type of techniques we can use if we plan carefully from our inception. Yeah. Yes. Yeah. So similar photo here. This cement stabilized roads can be constructed using machinery. Here, this you can see a cement stabilized road used inside the factory premises. So they also with the other advantage is that you can minimize the heat. This is called the heat island effect. So when you have paved surfaces, it increases the radiation, the reflection. With that again it affects the buildings and then you unnecessarily consume electricity on the air conditioning. So with that this type of solution we can reduce the energy demand. I hope I yes. Yeah, this is the famous art center I mentioned. There they have adapted this type of technologies. Yeah, another view of the same building. You can see no plastering in the finished layout. So, and also the using low heat emitting water-based paint, low heat emitting water-based paint. By using that also you can reduce the energy consumption. So these are the techniques we can use. Yeah, this is the earth tram construction used in the southern part of the country. So this is put into use, and now I think the research they done by one of our leading engineering faculties, they have successfully proven it as a product we can use in the for the practical usage. After that, you can complete it like in a normal construction, you don't feel it. It also rammed earth, you can see after completion. And similarly, rammed earth wall houses are being built. Now there's one model village for poor people. They need a house to live, and then at a very minimal cost. So this type of construction can be done, and also the advantage the material you can find from the location itself. So these are this done in one place in Sri Lanka. So again, we have a library also built in the red walls. These are the views from the same building, interior views. And also later, if you want, you can do improvements which you want to do. Yeah, this is, yeah, CAC I mentioned. Then this is the other the innovative solution they have found with the panels with straw. Yeah. So this also they have done the lab test and confirmed that this can be successfully used, and now it has not come to the commercial usage, but it's possible because in countries like even India you have enough straw from paddy fields, so this can be successfully used in construction. So you can see some more photos. So this similar material with Dura done in gold. So this is a two-story house you can see. So this is to convince the public the load testing. Environmental friendly load testing they done with the slab. I think you don't need any test reports when the elephant can sit on it. That's good enough for to say. So this was done in the demonstration. And also multi-story buildings with steel frame and precast panel. So this also sometimes means, if you look at the construction industry today, we waste a lot of resources because of the technological gap. Maybe if you look at the single story or two-story building, no engineering inputs are normally used. This is only the experience. We call it Vasudhane in our language. So they do the same thing, whether it's a strong ground, poor ground, whatever the ground condition, whatever the topography, they know only one technique, they use it. We know as per the engineering basics, if you have using columns or the beams, you need columns to transfer it. And sometimes structurally we have load bearing walls, then you don't need columns. So but still, if you look at the way the construction are done, you have huge columns, again thick load bearing walls, on top of that beam, everything. But if you analyze it, do we need all this? No, but unfortunately, these are not regulated, though we have various stages of approvals in various councils or the local bodies. Even there are technical officers, nobody looked at. So we waste lots of resources. Sometimes even a building or a factory building, maybe we can go with a solution like steel frames and precast metal. It can be a good solution. So, but we are not looking into this. So this also one aspect we need to look into, because we have no right to waste resources, world resources. Okay, one can say this is money is spending. No, but this is resources belong to all of us, and especially for the future. So again, similar thing, retaining walls done with foundation with CSR material. Yeah, another view of that building I mentioned. Yeah, I think you can go into detail because so various possibilities are there in the construction industry, and these are especially this type of construction now widely used in Sri Lanka is very cost-effective solution, and sometimes you have the problem in convincing the people because they are scared to even a chartered engineer certified. They say no, we are not sure this type of construction whether we can use. So, the possibilities the government can, in their installation, they can use and show it as proof. So there are many ways we can do, and we need to start immediately if you are truly concerned about the future sustainability. You can see the wide span without columns. Or they have. So eco roofs. So with the roofs, I mean, if you look at as I said, we cover inside as much as possible and use artificial light, and also we expose the roofs and put air conditioners to lower the heat. So if we can avoid that in the planning stage itself, we can make a very successful, sustainable design. So these are some examples about it in practice in our country. Yeah, this is the factory premises I mentioned. I'm sure in India you must be having lots of examples on this. This using the same technique, they have gone up a 3-story building, and I think there's a photo from they did the load testing also to show with lots of sandbags. Yeah, this one, yeah, you can see using this EPS expanded polyethylene panels. So the rural housing problem is a serious problem in most of the countries, especially developing countries. I think this type of solutions can help a lot. And we can, with a minimum investment, we can help a large population. So it's necessary that we concentrate on this type of technology. Yeah, this is a similar one for going for a 2-story, pre-stressed beams. And on that we use construct slab without folds. Okay. Even the staircases, if you can fabricate, you can make lots of savings, material savings, and the cost savings. Now this is the one I mentioned. So they are doing load testing with sandbags to show that it's strong enough to withstand like in a normal building. So this is a one tube. You can see the lightweight blocks with EPS. It's all wasted plastic you use, and with that you can save a large quantity of main materials you need for a building. So then we talk about the green technology. I think green buildings. I think there are many out-of-the-box solutions you can find out and make a building green building. So, and especially we have the green technology for that. In Sri Lanka, we have the green building council. So they especially look at it and they promote. If you have a rainwater harvesting system, then you get points in the approval process. I think in India it's also compulsory, as they have learned in some states of whole India. So there are many such areas we can do. Yeah, then the challenges of green. Yes, we can say the green technology, but still it's associated with the cost. So that cost can be cut down by innovative solutions only. So these are the areas I think as university, the academia and the industry need to get together and do research. Still, wide area to be covered to find out solution. Yeah, yes. Then finally, I just wanted to mention about the role of AC in the sustainable development. If you go to AC website, there's a separate section for sustainable development and for innovative solutions. We have 2050 plan. So floating cities and various concepts have been proposed to address the future sustainable targets. So when you are free, you can refer to our website and also collect, read and gather very important information from there. Then how to show as a professional body how we are prepared to or working towards the sustainable development in the future. Yeah, this you can see the alternative energy. Under that program I mentioned, that they are concentrated on alternative energy and autonomous vehicles, climate change. So if you go into details, you'll find wide area of information on these main areas and also other areas that they are planning to implement in the future. Yes, smart cities, and high-tech construction, advanced materials, policy and funding. Actually, this is also more important. Rather than we can just do research and find out various alternative solutions. At the same time, we need to be ready with the regulatory mechanism to implement it. So that's also an important aspect. Sometimes we have forgotten, but there we have paid attention already how to address the policy issues as well as the funding. So with that, I would like to conclude my presentation. So basically, I try to emphasize you the need of the sustainability, why we need to be concerned about this main area, and then as the next step to be innovative. In your conference, I went through the proposed program. It has addressed mainly all the sectors, and very interesting papers are there I saw. So I think this is what we do, and thank the Dr. Vasudev and the team for organizing this, selecting this